Harivam, my dear children. Today we are going to see the topic of properties of phenol. Properties of phenol, the next one is that physical properties and chemical properties we are going to see today. Phenol is colorless, needle-shaped crystal, hygroscopic, corrosive and poisonous in nature. It turns pink on exposure to air and light. The simplest phenol or liquids are low melting solids. They have quite high boiling points. Phenol is slightly soluble in water because of hydrogen bonding we have seen already. Yes, coming to the chemical properties. Chemical properties as like ether, the reaction involving OH group and the electrophilic substitution reaction. Okay, the reaction with zinc dust. Why the phenol is reaction with the zinc dust? Because zinc is a hard metal. It couldn't react the metal. It takes time. So the phenol react with the zinc. Phenol is converted to benzene on heating with zinc dust. In this reaction, the hydroxyl group which is attached to the aromatic ring is eliminated. See here OH. The hydrogen is going to that here on hydrogen. Zinc oxygen is combined with zinc to form a zinc oxide. The reaction with ammonia. Phenol on heating with ammonia in the presence of anhydrous zinc chloride gives aniline. See, phenol reacts with ammonia. Here is that OH, water is eliminated and aniline is formed. NH2 is attached to the benzene ring. The aniline is formed is very important reaction. And coming to the formation of ester. Ester we have seen already in the esterification reaction. So that is ester is phenol plus acid. Here phenol plus acid chloride. Acetyl chloride and benzoyl chloride. Acetylation and benzoylation is taking place. See that acetyl chloride, HCl is removed as a HCl, H from phenol, Cl from acetyl chloride, the HCl is removed. And coming to that next reaction, phenol plus benzoyl chloride, CH from phenol and Cl from benzoyl chloride, HCl is removed. The remaining acetate you add it and write the phenyl acetate and phenyl benzoate is formed, which is very easy. This naming is called as, this reaction is named as Scott-Bauman reaction. In the examination, how is phenyl acetate formed, or write the Scott-Bauman reaction. In two other chance to ask the questions in the examination. And coming to the formation of ether. Ether is a Williamson ether synthesis. We have studied in ether lesson. See, alkaline solution of phenol which is react with it. See here, phenol, NaOH is added, ONA, sodium phenoxide is formed, followed by methyl iodide. It is anisole. Anisole is aromatic ether. Yes, very good. Aromatic ether is formed. The next one is the oxidation. Oxidation is oxidizing agent, acidified potassium dichromate, and phenol, concentrated sulfuric acid is acting as a catalyst to induce the reaction very fast, and this OH group is hydrogen is eliminated as a water and one more oxygen is added here, 1,4-benzoquinone. How is phenol is converted into 1,4-benzoquinone? Question will be arised like this. And reduction reaction, phenol reduction means addition of hydrogen. See here, alternate double bond is removed here. Phenol is converted into cyclohexanol by the addition of hydrogen, and nickel is acting as a catalyst at 160 degrees Celsius. The reduction reaction for phenol. So what we have seen, see, this is a reaction with zinc dust. That is first one. Phenol, when you add a zinc dust, it form a benzene and zinc oxide is removed. Okay, and finally the reaction with ammonia, the phenol, ammonia, H from phenol, OH from phenol, H from ammonia, released as a water, removed as a water. Okay, And next one is a Scott-Bowman reaction, is formation of ester, you remember it. Here phenol plus acetyl chloride and benzoyl chloride we have to take it as. And the next one is the Williamson ether synthesis. In this Williamson ether synthesis, by using phenol is aromatic alcohol, aromatic ether is formed. And then reduction reaction, before reduction oxidation of phenol by using oxidizing agent acidified potassium dichromate with concentrated sulfuric acid, 1,4-benzoquinone is formed. The reduction reaction of phenol, addition of hydrogen and nickel is acting as a reducing agent at 160 degrees Celsius, cyclohexanol is formed. And coming to reactions with the benzene ring, it is a reaction with benzene ring nale, that is the electrophilic substitution reaction, that is electrophilic substitution reaction. See that? Reactions with benzene ring, electrophilic aromatic substitution. First one is nitroso. This is that nitro group is attached to here. Here nitrating mixture, here nitration, so it is nitrous acid. Nitration அப்படினா NO2 group add ஆகும். இங்க nitration அப்படிங்கிறதுனால NO group attach ஆகுது, and which is strong reactivity, so it is that gives a priority, so it is a para nitrophenol is formed. The next one is high nitrating mixture, that is orthonitrophenol and para-nitrophenol is formed. Here the sulfuric acid is also added here. And coming to the, it's very important reaction, already we have named, we have seen in the nomenclature, it's a picric acid, 2,4,6 trinitrophenol, which is called picric acid. How is it formed? Phenol, a nitrating mixture, concentrated sulfuric acid and concentrated nitric acid at 298 Kelvin. The 2,4,6 trinitrophenol is formed, and how many water molecule is removed? 3 water molecule is removed. So how many nitric acid is involved here? 3 nitric acid, H from nitric acid and oxygen from nitric acid. How it is splitted at nitric acid? OH minus, NO2 plus. Electrophile is always a positive charge. This NO2 plus is attached on the position, and hydrogen from benzene ring is added OH and released as a water. So the nitric acid is split into OH minus and NO2 plus. NO2 plus is the electrophile. Okay, my dear children, yes, NO2 plus is the electrophile, so NO2 is added here. And what are the positions? 2,4,6 trinitrophenol. It's very important reaction. Coming to that, sulfonation. Sulfonation is that sulfonic acid. How it is sulfuric acid is splitted? H2SO4 and SO3H, OH minus, SO3H plus. Always electrophile is a positive charge. Okay, nucleophile is the minus charge. So SO3H plus is an electrophile, is attached to the benzene ring. The OH group is the deactivating group of ortho and para direction. So orthophenol sulfuric acid and paraphenol sulfonic acid is formed. Okay, my dear children, these are the very important reaction for the electrophilic substitution of reaction. The next one we are going to see the bromination reaction. Yes, bromination, Br is added as like picric acid. Here is bromine and water is used. And here is the bromine and CCl4, carbon tetrachloride, which is helpful for the ortho and para directing isomer is formed. Okay. And here only addition of water, 2,4,6 position is formed. Instead of water, carbon tetrachloride is added here to form ortho and para isomers. The next very important two naming reaction is Cope-Schmidt reaction and Riemann-Tiemann reaction. In the examination point of view, these two reactions are very important, and repeatedly asking this question for the detail and 2 marks, 3 marks, whatever may be. Yes, here is the phenol, sodium hydroxide, sodium phenoxide is formed. Number of times we have seen NaO is attached here, HOH is removed as a water. Okay, my dear children, yes. Sodium phenoxide, addition of carbon dioxide. Second step, what do you have to add? Carbon dioxide at 400 K, 4 to 7 atmospheric pressure, followed by the acid COO. Na is shifted here. Na is shifted here. Where is shifted here? Na ortho position la shift ஆகுது. அப்போ sodium salicylate is formed. This sodium salicylate is hydrolysis HOH. NaOH is removed as a byproduct, and the phenol ortho position acid is added, that is called as the salicylic acid. We have studied in the carboxylic acid lesson la in the preparation படிப்போம். இதே திருப்பி படிப்போம் நம்ம, சரிங்களா? Okay, and then what is, I repeat again, phenol, addition of sodium hydroxide, sodium phenoxide is formed. The second step, we have to add addition of carbon dioxide, 400 K temperature, 4 to 7 bar atmospheric pressure. The ONA and COO is attached to the ortho position of the phenolic group and followed by the hydrolysis OH and salicylic acid. The position of the OH to the ortho position is the COOH group is added. This is called as salicylic acid. And coming to the Riemann-Tiemann reaction, here Riemann-Tiemann reaction is that the reagent is very important. Here is a chloroform. What is the formula for chloroform? CHCl3, and it is a basic NaOH is added. In the basic medium, the chloroform is added, and instead of carboxylic acid group, here aldehyde group is added in the Riemann-Tiemann reaction. Here is that CHCl2, which is unstable, followed by NaOH, that ONA is added, and followed by salicylyl aldehyde is prepared. ONA, CHCl2, and here is changed into CHO. After that, here is that OH group is changed. This is very, very important reaction both. Okay, the next one is phenolphthalein preparation. How is phenolphthalein preparation or thallium fusion? We have used phenolphthalein in our laboratory. Have you heard this word? Yes, which is used as a indicator, which is prepared as a phenol plus phthalic anhydride. Phenol plus phthalic anhydride. See here, 2 moles of phenol. Here is 2 moles of phenol, and H2O is removed as here. How? H, இதில் ஒரு H, இங்கே ஒரு H, இதில் phthalic anhydride இருக்கிற oxygen. என்ன ஆகும்? வாட்டராக ரிமூவ் ஆகிடும். What is removed? Water is removed. After remove the water, you combine together and write it as like a thallium fusion reaction. Okay, yes. The next one is coupling reaction. This is also very important reaction. Here is the dye is prepared. How is dye preparation? Otherwise coupling reaction, otherwise para hydroxybenzone. 3 different types of question may arise in the examination. Benzene diazonium chloride plus phenol gives NaOH 273 to 278 Kelvin. Here H from phenol, Cl from benzene diazonium chloride, not this H, here is the H இருக்கணும், அந்த Hம் இந்த Clம் சேர்ந்து HCl ரிமூவ் ஆயிரும். இந்த OH அப்படியே தான் இருக்குது பார்த்துக்கோங்க, and N2, இந்த N2 அப்படியே இருக்குது. 2 benzene ring, 2 benzene ring அப்படியே இருக்குது. Just you add HCl is removed and H from that புணர்ச்சி விதி சொல்வாங்கல்ல, வரப்போகிற காம்பவுண்ட் வரும், அந்த மாதிரி வரப்போகிற ஃபீனாலில் இருக்கிற ஹைட்ரஜனை Clோட சேர்ந்து ரிமூவ் பண்ணிட்டீங்க அப்படின்னா you get the para hydroxybenzene. Okay, this is both Riemann-Tiemann, Scott-Bowman, and thallium fusion coupling reaction. These are the naming reactions are very, very important. And coming to the how to differentiate alcohol and phenol. Alcohol is react benzene diazonium chloride to form orange diphenol. இதே alcohol வந்து benzene diazonium chloride ஓட aliphatic alcohol react பண்ணா dye form ஆகாது. And the next one is that purple coloration with neutral ferric chloride. We will do it in the laboratory. When school ஆரம்பிச்சோன்னா நம்மக்கிட்ட phenol இருக்குது, neutral ferric chloride இருக்குது. We will do this experiment, and the last reaction is ethyl alcohol does not react with NaOH. Absolutely, phenol only react with NaOH and form sodium phenoxide. These are another 2-mark question. And coming to uses of phenol, the phenol is used for making phenol formaldehyde, that is resin, backlight. இந்த கிளாஸில் நான் நிறைய தடவை சொல்லியிருப்பேன். நம்ம வீட்டில் யூஸ் பண்ணுற எலக்ட்ரிக் switches are made up of backlight, which is do not melt. What happen, it will not melt because electric fire extinguishers ஏற்பட்டுச்சுன்னா அதில் வந்து ஃபயர் ஆகாமல் இருக்க கண்ட்ரோல் பண்ணுறதுக்காக தான் ஸ்விட்சஸ்லாம் வந்து பேக்லைட். அந்த பேக்லைட்டை ப்ரிப்பேர் பண்ணுறதுக்கு phenol formaldehyde தான் யூஸ் ஆகுது. And phenol is a starring material for the preparation of drugs such as phenacetin, solol, aspirin, phenolphthalein indicator, explosives like picric acid. It is used as an antiseptic and carbolic lotion and soaps. Okay, my dear children, today up to this for you the July monthly test and preparation properties of phenol and alcohol or the remaining portions. Okay, thank you. Study well and write the test. We will recall the next section. Okay, thank you.